incomprehensible and shrouded in mystery, we were able to begin exploring beyond our home planet as a result of our insatiable desire for knowledge and the advancement of technology. This caught the interest of scientists even further, and soon, new space explorers left Earth to travel to various parts of our solar system to see what wonders lay in the vastness of the cosmos. On April 15, 2021, the spacecraft known as Pioneer 10 and Pioneer 11 were the first to pass the threshold of 50 astronomical units distant from the Sun. Since none of these space travelers are anticipated to pass the mark a second time, it is quite unlikely that any of them will return to Earth in the foreseeable future. It was on January 19, 2006, that the New Horizons spacecraft got its mission underway. It arrived at Earth after traveling 52 astronomical units at a speed of 14 kilometers per second, which is equivalent to 3 astronomical units each year. The major aim, similar to those of other interplanetary space probes, was successfully completed in operational condition for the Pluto and Kuiper Belt Object (KBO) mission. The New Horizons spacecraft, on the other hand, completed a gravity assist maneuver close to Jupiter before departing for its destination. This not only significantly increased the spacecraft's speed, but also enabled it to acquire high-quality images of the planet with the most satellites in the solar system, which is also the largest planet in the system. After the gravitational boost had been successfully completed, the probe continued on its journey toward Pluto's primary target, which it eventually accomplished in January of 2015. The major purpose of the mission was to take photographs and create detailed maps of the terrains of Pluto and KBOs from a range of perspectives, in addition to collecting information on their atmospheres and the features of their surface reflections. The probe also assessed the values of the magnetic field surrounding the objects as well as the activity of the solar wind. It goes without saying that the mission also involved enhancing measurements of Pluto's orbital characteristics and hunting for Pluto's satellites that had not yet been discovered. Both Kawa R1 and Durath were found thanks to the cameras on the probe, which continued on past Pluto's orbit after the original mission had been completed. It was determined how far away the star is from both Proxima Centauri and Wolf 359. New Horizons is expected to continue its journey beyond the solar system until it reaches a distance from the Sun of 100 astronomical units in 2038, at which point it will no longer be able to operate. Its power source, the radioisotope generator on board the spacecraft, is expected to start running low in 2026 and eventually shut down one by one. This issue was present for both Pioneer 10 and Pioneer 11. Therefore, they were both affected. The Pioneer spacecraft began their mission on March 3, 1972. They were traveling at a pace of around 12 kilometers per second, which equated to approximately 2.5 astronomical units per year. Their distance from Earth was 127 astronomical units when they encountered their escape route, already outside the solar system's boundaries. Although the major purpose had been successfully developed, it was not yet in a condition to function fully at the time. After traveling through space for a total of 641 days, the spacecraft arrived in the Jupiter system on December 4, 1973. At this point, images of Jupiter's surface and its largest satellites were beamed back to Earth, along with measurements of Jupiter's atmospheric composition and magnetic field. All of these observations were made after the spacecraft had traveled through space for 641 days. It was also found that Jupiter emits thermal energy at a rate 2.5 times higher than the amount it takes in from the Sun. We now have a better understanding of the features of the gas giants and the satellites that they deploy as a result of the data gathered back then. Even though it was on its route to Saturn, the second gas giant in our solar system, the Pioneer 11 spacecraft's primary mission was to investigate Jupiter's moons. Its scientific instruments assessed the magnetic field of the planet, and the onboard cameras recorded many photographs of the gas giant, its rings, and its 2 satellites, Titan and Mimas. Both Pioneer 10 and Pioneer 11 continued their trip toward the Sun, but the final signal received from Pioneer 10 was in the year 2003, while the last signal received from Pioneer 11 was in 1995. The Pioneer spacecraft were sent into space considerably earlier on September 5, 1977. At a distance of 154 astronomical units from Earth, they are currently moving at a speed of around 17 kilometers per second, which is equivalent to 3.6 astronomical units per year. It is believed that both are currently racing past the limits of the solar system, and there is no chance they will ever catch up with either of the two probes. The principal focus of this endeavor was Jupiter and Saturn, and they have successfully completed their missions, although they are not yet functioning to their full potential. The exploration of the solar system has been greatly aided by the cameras aboard the Voyager 1 spacecraft. Among the many achievements of this mission are the discovery of additional Jupiter satellites and rings, as well as evidence that the large red spot on Jupiter is, in fact, a gigantic storm. In addition to the many photographs that were taken of Neptune and its satellites, the onboard meters of the spacecraft sent a plethora of data on interstellar plasma. It has been a significant amount of time since both the heliopause and the Kuiper belt of our solar system were excited by Voyager 1, and the spacecraft is currently speeding through the scattered disk of the solar system on its way to the inner boundary of a hypothetical cloud. This spacecraft is the first one to have traveled farther from the Sun's center than any other spacecraft before it. Scientists were given a once-in-a-lifetime opportunity to study the heliopause thanks to Voyager 1, which was able to travel to this region of space, where charged particles emitted by the star collide with rarefied plasma to form elaborate structures made up of elementary particles and magnetic fields. The heliopause is the point in space where the pressure of the solar wind and the pressure of interstellar gas are equalized. It is anticipated that Voyager 1 will reach the inner limit of the Oort cloud in around 30,000 years. After that, it will pass by the star Gliese 445 at a distance of 1.6 light-years before vanishing into the endless depths of deep space. When talking about Voyager 1, it is impossible not to include its twin, Voyager 2, which left Earth on August 20, 1977. This mission was begun by NASA, and in addition to Saturn, Uranus, and Neptune, Voyager 2 headed for Jupiter to benefit from the planet's exceptionally strong gravity. The photographs obtained during this journey led scientists to the conclusion that Ganymede and Europa both have seas located deep underground. When Voyager 2 got near Saturn, it measured the temperature and magnetic field of the gas giant, leading to the discovery of many more satellites. It should go without saying that the probe also managed to capture numerous photographs of Saturn's surface as well as its rings. The next planets to be investigated were Uranus and Neptune. It was also found that both Uranus and Neptune had rings that were affected by Neptune's gravitational pull. Hence, the spacecraft had to modify its course and leave the ecliptic plane in order to complete the flyby. Despite this, the probe still had a lot of fascinating things ahead, such as gathering important data on interstellar plasma and cosmic wind, determining the distances to stars, and investigating the heliosphere. At this time, the probe is located 128 astronomical units distant from the core of our solar system, and the gap between it and Earth continues to widen at a rate of 15.37 kilometers per second. Voyager 2 will be located at a distance of around 1.7 light-years from the start, and there is a possibility that it will fly by Sirius at a distance of 4.3 light-years. This likelihood occurs once every 300,000 years. Interplanetary space probes are simply mankind's first cautious steps in exploring the boundless cosmos. Thus, it is important to anticipate what will happen to them in the future, as we are still in the early stages of space exploration. There is a chance they will be destroyed when they come into contact with a celestial body, but there is also a chance they will be retrieved from interplanetary space by our distant descendants, who will have developed interstellar travel technologies to the point where they will be able to do so. As humanity ventures further into the cosmos, the complexities of space exploration continue to challenge our understanding of the universe. While our early missions were primarily focused on exploration within our own solar system, they have since paved the way for more ambitious missions, aiming to explore exoplanets, distant galaxies, and even the very fabric of space-time itself. The technology and knowledge we are developing today will, in the future, allow us to look further and deeper into the universe, possibly even reaching areas we once thought were beyond our grasp. One of the major challenges that come with space exploration is the vast distances involved. For instance, traveling to even the closest stars beyond our solar system would take tens of thousands of years with current propulsion technology. Scientists are now exploring ways to increase the speed of space travel, such as theoretical propulsion systems like the warp drive or ion engines. These technologies, while still in the realm of theory or early development, could one day allow us to send spacecraft to distant stars in a matter of decades instead of millennia. In addition to advancing propulsion technology, scientists are also working on improving spacecraft durability. Space is an incredibly hostile environment, filled with radiation, extreme temperatures, and micrometeoroid impacts. The materials used in spacecraft must be able to withstand these conditions for long periods of time. Current spacecraft, such as those sent on missions to distant planets or the Voyager spacecraft, are equipped with shielding to protect them from radiation and space debris. However, these protections are not perfect, and future spacecraft will need even more robust and innovative designs to ensure their safety during long-duration missions. Another area of focus in space exploration is the search for extraterrestrial life. Missions to Mars, Europa, one of Jupiter's moons, and Enceladus, one of Saturn's moons, are focused on finding signs of microbial life or even more advanced forms of life. Scientists believe that these moons, which are thought to harbor subsurface oceans beneath their icy crusts, may be some of the best places to look for life beyond Earth. The discovery of even the simplest form of life in these environments would be a groundbreaking achievement, expanding our understanding of the conditions under which life can arise. As we search for life, we are also developing tools to detect and study exoplanets, planets that exist outside our solar system. The discovery of thousands of exoplanets in recent years has been one of the most exciting developments in the field of astronomy. Some of these exoplanets are located in what is known as the habitable zone of their stars, where conditions might be right for liquid water to exist, one of the key ingredients for life as we know it. The James Webb Space Telescope, launched in December 2021, is expected to play a key role in studying the atmospheres of these distant worlds. By analyzing the composition of their atmospheres, scientists hope to find signs of biosignatures, chemical markers that could indicate the presence of life. One of the most ambitious goals of space exploration is the potential for human colonization of other planets. While this idea might seem like something out of science fiction, advancements in technology have made the concept more feasible than ever. NASA's Artemis program, for example, aims to return humans to the moon by 2025, with plans to establish a sustainable presence there by the end of the decade. The moon could serve as a stepping stone for future missions to Mars and beyond. Establishing a permanent base on the moon would provide a critical testing ground for the technologies and systems required to support human life on other planets, such as life support systems, radiation protection, and the ability to grow food in space. Mars is often considered the next logical target for human exploration and colonization. Its relatively Earth-like conditions, such as its day length and the presence of water ice beneath its surface, make it an ideal candidate for human settlement. However, living on Mars presents significant challenges, such as the planet's thin atmosphere, extreme temperatures, and lack of a magnetic field to shield against harmful radiation. NASA and private companies like SpaceX are actively developing spacecraft and habitats capable of supporting human life on Mars, with the goal of sending the first crewed missions to the Red Planet within the next decade or so. As we push the boundaries of human exploration into space, we also face a growing need for international collaboration. Space exploration has historically been a cooperative effort between nations, and this spirit of collaboration is essential for future missions. The International Space Station, ISS, is a prime example of how countries can come together to share resources, knowledge, and expertise in the pursuit of scientific discovery. As the scope of space exploration expands, cooperation will be key to overcoming the vast technical, financial, and logistical challenges that lie ahead. Moreover, private companies are playing an increasingly significant role in space exploration. Companies like SpaceX, Blue Origin, and others are revolutionizing the industry by developing reusable rockets, reducing the cost of space travel, and expanding opportunities for commercial ventures in space. These companies are not only helping to build the infrastructure for space exploration, but they are also opening up new avenues for space tourism and even asteroid mining, which could provide valuable resources for future space missions. Looking to the future, the potential for space exploration is limitless. While we are still in the early stages of exploring our own solar system, the next few decades promise to bring exciting discoveries and advancements in space technology. With continued innovation and collaboration, humanity will one day unlock the secrets of the cosmos and perhaps even establish a permanent presence beyond our home planet.